Alright, today we're going to look at solving exponential and logarithmic equations. And so an exponential equation is just an equation that contains a variable in the exponent. So it's got an exponential function in there somewhere. And the first method we're going to look at is to just express the equation as something with the same base raised to some power m equal to something to the same base raised to some power n. And then once you've done that, then you can set m equals to n and solve. So that's just a recap of these two steps here. First you find the same base, and then you set the exponents equal to each other. So now for example 1 here, what we're going to do is we're going to write these in the same base. And so if you look at 4 and 8, they're both multiples of 2, right? So 4 equals 2 squared and 8 equals 2 cubed. So what that allows you to do is that allows you to note that this is really 2 squared raised to the x minus 3 equals 2 cubed raised to the x plus 2. And now if you know your properties of exponents, 2 raised to the 2 raised to the x minus 3 is the same as 2 times 2, or 2 raised to the 2 times x minus 3. Okay, so you can just multiply the exponents. And the thing on the right is 3 times x plus 2. So it's 2 raised to the 3 times the quantity x plus 2. And now that we have these in the same base, we can set m equal to n. So we can set 2x minus 3 equal to 3x plus 2. And now we solve for x, so that this equation here implies that equation there. Oh, I need to put parentheses around the x minus 3 there, right? That's a common mistake that people make when solving these things. Now I need to distribute, so I should get 2x minus 6 is equal to 3x plus 6. And so that will give me, let's see, if I subtract negative 3x from both sides, if I subtract 2x from both sides, let's say, then I'll be left with an x here, and I'll be left with negative 6 there, and then I subtract 6 from both sides, I get x equals negative 12. Okay, so there's the solution to the first equation. Now we should try to do the same thing for part B, and if you look at this, you should be able to figure out that the common base here should be e. So e 1 over e cubed can be written as e to the minus 3, right? So then you get e raised to the x plus 8 is equal to e raised to the negative 3. And now I can set the two exponents equal to each other. X plus 8 must be equal to negative 3. So x plus 8 equals negative 3 implies that x must be equal to a negative 11. Okay, perfect. Now in method 2, you want to use natural logs to solve the equation. So this is a better method because it's more general. It will work more often. The first method is nice because if you have the same base, then you don't have to bust out your calculator. You can just set the exponents equal to each other. But if you have different bases, or if you have one side that's exponential and the other one's a constant, then you want to use natural logs. So the three-step process here is to isolate the exponential expression. So put it on one side of the equation by itself, take the natural log of both sides, and then simplify using the power rule for logs and solve for the variable. So let's try this. If we have 6x minus 2 equals 331, then we can either take log base 6 of both sides, or we can take natural logs of both sides. I kind of prefer taking natural logs, just because it's easier to punch into your calculator than log base 6. Okay, so you should get ln of 6x minus 2 equals natural log of 331. And then using the power rule, this becomes x minus 2 times natural log of 6 equals natural log of 331. Again, that was using the power rule, so what we did there is we took the exponent and we brought it out front of the log, log 6. And now log 6 is a constant, so we can divide both sides by natural log of 6. Right? And you should get that the x minus 2 then is equal to the natural log of 331 over the natural log of 6. So that means that x is equal to the natural log of 331 divided by the natural log of 6 plus 2. And that should be your final answer. And you could simplify it down, but this is really the answer I'm looking for. If you're plugging this into a calculator, you'd get a decimal approximation, which isn't exactly the same answer. That's preferable in some cases, but in math we like to keep things as pure as possible, so we won't actually do any rounding right now. Okay, now in this next example we have two different exponential functions with different bases, right, 2 and 3. So what we're going to do is we're going to, again, just apply natural log to both sides, and so we should get natural log, so that's natural log of the 2 times 4x minus 2 is equal to natural log of the 3 times x minus 2, or raised to the x minus 2. So this is 2 raised to the 4x minus 2 power. This is 3 raised to the x minus 2 power. And now we use the power rule to move these exponents out front. Okay. So I should get 4 times x minus 2 times natural log of 2 is equal to x minus 2 times natural log of 3. And now what I want to do is I want to distribute the natural log of 2 in front of the 4x and in front of the 2, and then I'm going to distribute the natural log of 3 in front of the x and in front of the negative 2. And that will then allow me to reduce this to an addition and subtraction problem. So okay, this is natural log of 2 times 4, so I'll write that as 4 times natural log of 2 times x minus 2 times the natural log of 2 equals natural log of 3 times x minus 2 times natural log of 3. And again, that was distributing that in here and here, and distributing this in there and there. And now that we've done that, now we just combine like terms by addition, right? So there are the constants underlined in red, and there are the things involving x underlined in blue. So I'm going to move everything in blue over to the left. So I should get 4 times the natural log of 2 times x minus the natural log of 3 times x equals the stuff I've underlined in red, which would be negative 2 natural log of 3 plus 2 times natural log of 2. Okay, and now the only thing I can do is factor out an x here. Okay, so that will be 4 times the natural log of 2 minus the natural log of 3 times x equals, let me reorder the red stuff in red just a little bit. I'm going to write that as 2 times natural log of 2 minus 2 times natural log of 3. That isn't required, but I kind of like moving things with negative signs over to the right so I don't forget that the negative sign is there, or get it confused with like the equal sign or something. And now the last thing you can do is divide both sides by that constant. So 4 natural log of 2 minus natural log of 3. And so now you've solved for x equals 2 natural log of 2 minus 2 natural log of 3 all over 4 natural log of 2 minus natural log of 3. And that's the final answer. Okay, now in this last one, we have 7e to the 4x equals 1064. So I'll start by dividing both sides by 7, and I get e raised to the 4x equals 1064 divided by 7. Well, that's 152. So I have e raised to the 4x equals 152. Let me write that down again. And now I'm going to take natural log of both sides. And when I take natural log of both sides, let me move that over a little bit to make it cleaner. The natural log of e is raised to the 4x is just 4x. And then I have natural log of 152. So that would be x equals the natural log of 152 divided by 4. And that's my final answer. Okay. Now we're going to look at, we've been looking at exponential equations, now we're going to look at logarithmic equations. Again, those are just equations that contain logarithms. And so now what we're going to do is we're going to take the log and raise it to either 5 to the x or 6 to the x or e to the x or something. So we're going to raise both sides to an exponential, which will cancel out the logs. And then it's really important to remember that you cannot take the log of a negative number. So if you've come up with a solution, but it would require that you take a log of a negative number, then that solution is not going to work. Okay? So we'll see that in a minute, how that comes out. So for this first one, what you do is you just replace log base b of m equals c with b to the c equals m. So in this case, we have 5 to the third equals x plus 9. Right? So this is, I'm taking log base b of m equals c, and I'm changing it to b to the c equals m, where m is x plus 9 and c is 3. Okay, so that is now 125 equals x plus 9. And now you subtract 9 from both sides, and you should get 116 equals x. And then what you should check is just to make sure that you're not taking log of a negative number. So if you have 116 plus 9, that's okay. That's not gonna be log of a negative number, so that's good. So this is the solution. Okay. Now in the second example, we have this sum of logs, and before we can replace log base b of m equals c, we need to condense. So we need to condense this using our log condensation rules, or power rule here. So you can write this as log base 6 of x plus 5 times x equals 2. So I just condensed, and now I can write that as 6 squared equals x plus 5 times x. Okay. Yeah. And let me just say that this is replacing that rule, but let me look at it the other way. Another way of looking at this is I'm taking log base 6 of x plus 5 times x, and I'm raising it to the 6th power. So it's 6 raised to that stuff here, and then equals 6 squared, and you end up with what? X plus 5 times x equals 6 squared. Okay? Now we just have to solve. So we have what? X squared plus 5x equals 36. Or in other words, x squared plus 5x minus 36 equals 0. And I think we can solve that by factoring. Let's see, that would be, what would add up to give me negative 36 and have a difference of positive 5. That'd be x plus 9 and x minus 4 equals 0. Okay, so then my solutions are either x equals negative 9 or x equals positive 4. Okay. And I'm going to say that these are my possible solutions. Remember, I need to check that I'm never taking the log of a negative number. And you'll see here that if I take negative 9 and I stick it in for x here or there, I'd be taking log of negative 9 or log of negative 4, and that would be illegal. Okay, so that one's not going to work. Okay, can't take the log of a negative number. If I plug in 4, it's going to be okay. So x equals 4 is only solution. Okay, so sometimes in doing this you might get some extraneous solutions because when you're raising it to the 6th power or whatever, you're allowing for the option of maybe having a negative 9 there, but then when you plug it back in, you see that would blow the logarithmic function up. Okay. So now we're moving right along. In method 2, what we're going to do is if you have an equation that's expressed in the form log base b of m equals log base b of n, so you have the same bases, then you can set m equals to n. So first thing we're going to do is we're going to condense. Sorry, this part right here, we need to condense that. So this is, starting off, we're going to condense using the quotient rule. So I'm going to have log base 2 of 6x minus 3 times 7, or sorry, divided by 7 is equal to log base 2 of x plus 1. And so then I can set 6x minus 3 over 7 equal to x plus 1. Okay. Let's see. So now to solve this, what we need to do is, we can multiply both sides by 7, and that will cancel that 7 on the bottom there. So I get 6x minus 3 is equal to x plus 1, and then okay. Sorry about that, I had a knock in my office door. And so, okay, so we're picking back up. We have 6x minus 3 equals x plus 1. So we can, 7 times x plus 1. Right. So now what we can do is distribute that 7. We'll have 6x minus 3 equals 7x plus 7. And then maybe I'll subtract 7 from both sides and add 6, or subtract 6x from both sides as well. And you should get negative 10 equals x. Okay, and so that's my proposed solution, or possible solution. And now I need to plug that back in up here and make sure that everything's okay. And you're going to see that if you plug in negative 10 in here, you're going to get log base 2 of negative 10 plus 1 is log base 2 of negative 9, and that does not work. Right, that's undefined, and so there's no solution. So that was our check, and so this says that there is no solution to this equation because the only possible solution would be x equals negative 10, but then that would require that you take the natural log, or log base 2 of a negative number, and you can't do that. Okay, now this last problem is actually a word problem, and we've already done a few of these already in this chapter, and so I'm going to let you guys try it on your own at home, and I'll just tell you the answer at the start of class. Alright, thanks.